Hello, I'm presenting on the content placement algorithms for cloud-based CDNs. So we know that the traditional CDNs have high maintenance costs and are not scalable for small-scale business organizations. So it's a better alternative to use cloud-based CDNs, with since nowadays cloud computing is in vogue and it offers many services. Let's go into the abstract. So, the content placement algorithms are widely used in cloud based CDNs and they're used to minimize cost and improve the quality of service. So, we can minimize the cost by efficiently designing the underlying CCDN architecture, and the quality of service is dependent on what content is placed on which cloud-based CDN and how close it is to user and so on. So this paper is a survey and it analyzes between different content placement algorithms and evaluates them against some state of the art well known algorithms. So let's go into the introduction part. This is a sample example which shows how an end user interacts with a cloud-based CDN. So the end user makes a video request, and it does the domain name resolution with the DNS server, and the DNS server responds with the IP address of the request router. So the client now approaches request router, and the request router redirects the request to all of its surrogate servers. So these are the surrogate servers, and the ones in the blue are the original servers. So depending upon how the companies implement surrogate servers, they can be primary surrogate servers, secondary surrogate servers, and tertiary surrogate servers, and so on. So the ones which directly interact with the user are called primary surrogate servers. So if the requested content is available in the surrogate server, it's going to respond back with that content. If it doesn't, it's going to fetch the information from the original server or from its neighboring surrogate servers. So it responds with the content. So the content has a data and metadata. Data can be static, dynamic, or can be value added contents. So static data is the video itself, which doesn't change, and the previously viewed information, which is directly stored in the browser. The dynamic content is the recommendations. So we need to personalize the video suggestions and come up with application logic to implement dynamic data. We also have value added content, which displays the advertisements, and then we have the metadata, which is basically a set of rules on determining what to update and how long the cache is valid and how you need to update the cache and so on. So let's look into how a content management system works. So the CMS determines where the surrogate servers should be placed and what content should be selected and delivered to the users. So which content should be placed is where the CPA algorithms come into play. So the CPA algorithms are generally push based or pull based. So we'll discuss more about it in the next slides. So the content placement problem is an NP-hard problem. So there doesn't exist a unique solution, say optimal solution in polynomial time. So let's look at the problem statement. So we got a bunch of surrogate servers, S1, S2, S3, S4, and an original server. So the original server has 5 contents, or say 5 items, T1 to T5, and there are a bunch of users across the globe. And so D14 says the user close to the surrogate server S1 is requesting item 4, and he's also requesting item 5. So the objectives here are to have the optimal number of replications of the items on each surrogate server, and and then to meet the quality metrics. So quality metric is something which is defined by the implementing organization, and we have to minimize the cost of hosting and delivery, and we need to efficiently use each surrogate server to its maximum capacity, and we should efficiently utilize the bandwidth across the network while keeping T, which is the uptime, the phi is the downtime, and Q is, I think it's the communication time. So these are all should be minimum while the bandwidth utilization should be maximized. So these are our objectives and this is our problem. So a simple solution for this problem would be to place T4 to T5, which is requested by user 1, on surrogate server S1, and so on. So this is a simple solution, but this is a very generalized case of content placement scenario. But we will run into a bunch of different factors which makes it very unfeasible to determine a solution, an optimal solution for this problem. So the content flow is managed using pull based and push based techniques. So pull based is a reactive algorithm. So if the requested information is not present in the cache, it's gonna request the information from its surrogate servers or from the original server and then respond back to the user. Whereas in push based techniques, it's a proactive type of algorithms, and they store they predict what the user might request and store it on the cache beforehand. So these are two different paradigms of content flow, content placement algorithms. So let's look at how this problem can be approached. This problem, as we talked, is an NP complete and also NP hard problem. So there doesn't exist any polynomial time solution, so we might have to use effective heuristics to get a feasible solution. So we have looked at some of the objectives in the previous slide. The main objectives are divided into they're divided based on the type of objective we are minimizing. So first, if we are trying to minimize cost, we need to minimize the storage and minimize the utilization of bandwidth and keep resources to minimum. And then if you're trying to minimize latency, we need to minimize all of this, which is round trip time, end-to-end delay, throughput, hop count, jitter, and geodesic distance, which is the distance between the user and the servers. And also it can be distance between the server and its neighbors or server from the original server. So, and rarely some of the networks also consider the state of underlying network. So we also want to have more content availability, which is quite rare, but it is still an objective we need to meet. Okay, so now let's see how we can set different parameters. So like any NP hard algorithm, we need to determine the parameter value by using heuristics. So we could use machine learning, we could use linear regression and some regression models along with, say, SVM, a support vector machine, and this another one the paper talks about, which deals with the Gini coefficient index, and this algorithms determine the parameter values. And we can also use some probabilistic distributions and the entropy and how different parameters. and how different parameters change by changing the entropy and so on. So these are some of the values which are derived using these techniques. So it says the static content image should be less than 10 power 4 bytes and so on. So let's see the content hosted on a cloud-based CDN. So this can be talked in three parts. The first one is the classical content, which has static and dynamic types. Each type has a document, and if a document can be further granularized to object. So it depends on the size and the freshness of the content. So freshness is the interval between the updates. The size of the document can be characterized using Pareto distribution. So these are some of the probability distributions, and the researchers have came up with these distributions for each individual case. The interesting one here is the bimodal distribution for the objects. So the objects exhibit two different states, one being one which gets updated very frequently, or one which doesn't get updated at all. Okay, next is the contemporary content characteristics. These include the mobility, interactivity, and online social networking relationships. So mobility is using mobile phones and use streaming data, say video and images. And a recent survey says 64% of global traffic is only video traffic. So it's important to analyze the characteristics of video content, which include the chunk size, the format resolution, the bitrate, and the playback mode. These are the two different types of video generations, types of videos on the network. So the UGV stands for user generated videos, which are generated in websites such as YouTube and so on, and VOD stands for video on demand. So Netflix has a huge catalog of videos, and you cannot upload any videos to Netflix, right? So if the user is having an option to upload videos, the user generates the content and it comes under UGV. So we can see that each video goes through three different phases. The first phase is the hot phase, where at the initial stages of the video, it goes viral, and it frequently appears in the recommendations list and in the search list, and then it enters into, say, after 7 days, it enters into warm phase. So it doesn't appear unless you search for it, and after that it slowly and drops into the cold phase, where it is rarely requested and basically goes into hibernation. This is the life cycle of a video which the authors have came up with, or the researchers have came up with. So the third important characteristic is the end user behavior and the online social networking relationships. So the end user, so a survey was conducted and 85% of end users watched videos which are under 90 seconds only. So the videos which are greater than 90 seconds were not replayed because of low quality of experience, or basically he's not interested. So OSN is basically if your video is referred using social networking sites and if it goes viral, we need to take that into account as well. So the design criteria of content placement algorithms is mainly divided into two types: the one which depends on content access patterns, and the one which depends on content popularity. So we design We design algorithms using content access patterns by taking the format into account. So different videos have different formats, and some websites like YouTube sends multiple video formats simultaneously using protocols such as Quick. And we need to take the spatial, temporal, and OSN relationships. The spatial relationships include, say, users in a specific geographic area are likely to watch these videos, and so on. The content popularity depends on the age, the character category, and and other variables, which we'll talk about them later. So, how do you evaluate CP algorithms for cloud networks? So, as we talked, there are two types: pull based and push based. So, pull based algorithms are of two types, or say two components. The first one, which determines or which gets the content en route from source to destination. So if you request the content from source, if it has the information, it's going to respond back. Otherwise, it's going to ask its original server, or its, say, secondary server or and tertiary server. If it doesn't find, and then it goes to the original server. So if it finds the content anywhere on the route, it's going to return. And hierarchical algorithms, so they follow a set of paths. Say the primary server directly asks for the content from its original server, and if it has the information, so the original server passes on to the primary server, and it then is passed on to the user. So the cache can be cooperative or non-cooperative. So cooperative cache is if cache treats every items equally, and so if a new item has to be inserted in cache, if it has a greater utility, then it's inserted. If it does not have a greater relevancy or utility, it's not inserted. Whereas in non-cooperative cache, every item is treated with the same utility. The algorithms also have different cache management techniques, where the size of the cache is different, and if the cache is consistent with the original or the neighboring servers. So the algorithms can follow different cache replacement strategies. It can follow pure strategies like least recently used or least frequently used and FIFO, or they can employ a mix of the pure replacement strategies such as LFU and FIFO. And another implementation strategy is using TTL cache. So it's going to expire after a predefined time period, which we'll talk about later. So the push based algorithms are divided mainly into two types: one which prioritize the content, and the one which prioritize the surrogate server. So if you're taking surrogate server into account, so you need to minimize the cost, improve the quality of service, and reduce the storage and increase the bandwidth. So you can see some of these are not mutually exclusive. So if you need to fully utilize the bandwidth, you need to lower the utilization of bandwidth, right? So in order to have less cost, but lower utilization of bandwidth would mean a less quality of service, which is not ideal. So coming into the algorithms which prioritize content, they need to take the demand, popularity, age, content category, which we talked about in the previous slide, into account. So these are some of the algorithms which the survey points out. We could see only two algorithms which are based on the pull based algorithms, which is SNA, GBSP, and the TTL based cache, which has a certain time to live and updates its cache after the timer expires. Okay, now let's see the research challenges which were identified by the paper in three different areas. The first one is a cloud model. Um, the first research area is to determine operational cost versus quality of service. They are not mutually exclusive, as we talked about in the previous slide. Some of the key challenges are the cost of hard versus soft quality of service metric. Hard quality of service metric is something which you need to follow, and soft quality of service is something you could approximate or have a close approximate solution. And the number of replicas for quality of service, the overhead of leasing or initializing resources for quality of service versus the delay which is incurred by leasing these resources. So these are some of the topics which require further attention. So the push versus pull algorithms, so we need to there's still some need of doing research on the effect of caching and the effect of pushing content and the net gain from either CP algorithms. So the resource provisioning, so there still needs some research to be done on balance between cost versus performance and utilizations of resource and their overhead. So, and even the size of surrogate server is which is directly proportional to the efficiency. This topic also needs further evaluation, as greater the size of the cache, we need more. It means more cost, but that would mean if it has more size, it has more efficiency, but we need to have less size, because basically if you have more size, it's going to cost you more. Okay, so the content characteristics, so in the popularity we need to find the correlation between popularity of videos and its related videos, and effect of personalization of content on CP algorithms. So use of dedicated media servers for video streaming, is it a possibility or not, is something we still need to find out. And so how sending multiple video formats which are device dependent, and if you're taking dynamic content, what to replicate, either the front end content, the back end content, or the application logic, or the whole user profile, or do you fully replicate or only replicate some stuff, say using partial replication, or is it availability versus consistency, and complexity and performance cost trade-offs should be further analyzed. So the end user behavior, the OSINT relationships, there's a lot of work to be done in this field. So how rarely are cold videos viewed and what is the threshold? So building some algorithms in the recommendation systems which can automatically depending on the recommendations, and the request prediction, so having an accurate prediction models and their effect, and the effect of using social networking on predicting the user's content request. So, so coming to the conclusion part, so there's a lot of traffic going on in the internet, and the most of them is attributed to video traffic. So around exabytes of traffic is going through the internet every month, and cost of setting a traditional CDN is not possible for small scale companies. So this survey paper has mainly focused on different algorithms, the evaluations, how to reduce cost, and the future research challenges. So that's it from me, and thank you for listening to the presentation.